So in this video, we're going to see a data structures question, which is from year GATE 2017 and is based on the topic of binary search tree. So let's read what the question is. The pre-order traversal of binary search tree is given by. So we already have a binary search tree on which pre-order traversal has happened, and we have got this as the sequence or this as the output. Now, the post-order traversal of this same tree is, and we have four options. We have to select one of them. Now, before we move ahead, let's quickly revise what is the pre-order traversal of a tree, or how a pre-order traversal of a tree works. So as you can see here, if this is my tree with plus as the root and A and B as left and right child, then the pre-order traversal of this tree is plus A, B. Okay. Now the point that we should note here is, first we visit the root. So let me write it down. First we visit the root, then we visit to the left of the tree, and then we visit to the right of the tree. So this is a quick recap of how pre-order traversal works. The root, then the left, and then the right. Okay, root, left, right. This is how we are going to visit. Now, since this is the pre-order traversal given, let me make a note of it quickly. So yes, so this is 12, 8, 6, 2, 7, 9, 10, 16, 15, 19, 17 and 20. Oh, many numbers are there. So this is the given pre-order traversal of a input binary search tree. Now as we all know, in the binary search tree, the values are less than the root to the left and greater than the root to the right. That's a typical property of a binary search tree. Okay. Now, as we just saw that in pre-order traversal, root is the first node that is always visited. Okay. So in this pre-order traversal, which is given to us, such a lengthy pre-order traversal, 12 is the first value. If 12 is the first value, then 12 is definitely the root of the tree, because that is the one which is visited first as per pre-order traversal. So very confidently we can say that 12 is going to be the root of my tree, because that is the first value here which is visited. Now since it's a binary search tree, all the values to the left are going to be less than 12 and all the values to the right are going to be greater than 12. Okay, because this is the property of a binary search tree. So let's quickly note down 8, 6, 2, 7, 9, 10. These are the values less than 12, and then 16, 15, 19, 17, 20. These are the values greater than 12. So now I'm going to apply the property of pre-order traversal even to these subtrees. Okay, so if in this subtree, as you can see, the first value that is visited is 8. So since 8 is the first value that is visited, again according to the pre-order traversal algorithm, root is always the first node that is visited. So in this subtree, 8 is again the root of the entire subtree. So I'm going to make a note of that. Okay, so 8 becomes my root, and everything less than 8 will be to the left and everything greater than 8 will be to the right. Why? Because this tree is also a binary search tree. It's not a binary tree, it's a binary search tree. So less than 8 becomes 6 and 2 and 7. Okay, and greater than this becomes 9 and 10. Now, once again, in this subtree structure, we are going to apply the pre-order traversal property. So I'm not going to repeat it again and again. Let's quickly write it. So the first value is always the root. So this is 6, and then less than 6 is 2, greater than 6. Less than 6 is 2 as well as 7. No, 7 is greater than 6. So here it comes. Here again 9 is the root. So 9 comes here, and there's nothing less than 9. So that's null, and greater than 9 is 10. So similarly, this same algorithm and this same steps you have to repeat even for this entire right subtree. So let's do it quickly. This one is the root. So 16 is the root. Everything less than 16, which is 15. That's it. Only 15 is less than 16. Rest all are greater than 16. So 19, 17 and 20. So this is greater than 17. Now again 19 is the root here, because 19 is the first value. So 19 comes here, and less than 19 is 17, and greater than 19 is 20. Okay, so in this way we have reconstructed the original binary search tree of whose pre-order traversal was mentioned in the given question. Okay, so let's quickly write down this original structure of binary search tree here. So I'm going to make it 12, and less than 12 is 8, and this one is 16. Okay, now less than 8 again is 6 here, and then we have 2 and 7. Okay, and here less than the 16. Okay, less than 16 is only one node, 15, and greater than 16 is 19, and then we have again 17, and we have 20. Okay, so the original binary search tree is reconstructed. Let me draw a line here so that there is no confusion. Okay, now they have asked us the post order traversal of this tree. Okay, so let's first quickly revise what is post order traversal of the tree. Once again, I'm going to take the same example as before. If this is my binary tree, let me write it down. Post order. So the post order traversal is going to be A, B plus. Okay, the post order traversal of this binary tree is going to be AB plus. Now once again, let me zoom in. Once again, the point to be noted is the first thing we visit is the left. Okay, the first thing we visit is the left of the tree, then we visit the right of the tree. Okay, and then finally we visit the root of the tree. This is how the post order traversal of a tree works. Now this same post order traversal of the tree we are going to implement on our original binary tree function. Original binary tree that we reconstructed. So we start from here. This is where I am 1. I start from the root, and we always visit the left first. So I come to the left, so here, then again I come to the left here, and then again I come to this left. Let me come like this. Okay, so 4. Now once I am at this node 2, there is nothing left at the left. Left is null. So once I'm done with that, then I go to the right. Okay, okay, this left is done. Left of 2 is null. Then I go to the right. Right of 2 is also null, and then I will visit the root as per the post order traversal algorithm. So 2 will be visited, and thus this is how 2 will come as my first value. Now once I'm done with this node, okay, I will go back. So I will go to 3. Now when you are at 6, you can see the left of the 6 is done. So this left is done. Now I have to go to the right. So I will go to the right of the 6. So I am going to come at this node 7. Now when I am at 7, left is null, right is null. So root will be visited. So 7 is going to be visited, and 7 will be my next output. Now we'll go back. 7 is done. I will come back to this 3 again. And now again, if you think about this node 6, left is visited, right is visited. Now the root will be visited. So 6 will be visited, and 6 will come here as output. So I'm going to strike back as 6 also. So 2, 7, 6 are my first 3 values of the post order traversal. Now let's have a look at the options. If there is only one option with 2, 7, 6 as first 3 values, we need not find the post order traversal of the entire tree. So let's zoom in. Okay, 2, 7, 6. Oh, we are lucky. So as you can see, let's zoom out. Okay, 2, 7, 6. So 2, 7, 6 is our, there's only one option, 2, 7, 6 with option B. There's no need to waste time in calculating the entire post order traversal. So very safely and very confidently, we can say option B is our right answer.